Hello class. Today we're going to talk about lesson 8.4, the division properties of exponents. So we already learned about some of the laws of exponents, mostly the multiplication laws of exponents. Now we're going to look at the division properties of exponents, or division laws of exponents. Our learning target today is to be able to use those division properties of exponents. Let's first take a look at the properties here. All right, so the quotient of powers property, and again, don't worry, I'm not going to have you memorize the names of each property. You just need to know how they work. So for instance, this one, when we divide powers that have the same base, we are going to keep the base and we are going to subtract the exponents, which this kind of makes sense because if you remember, when we multiply two powers with the same base, we keep the base and we add the exponents. Here we're doing just the opposite. If we divide powers with the same base, we keep our base and we subtract the exponents. All right, so something like this, a to the power of m over a to the power of n. We keep our base of a and we subtract our exponents. That is the quotient of powers property. We then have the power of a quotient property. To find the power of a quotient, or a fraction is another good way to think of that. We find the power of the numerator and the power of the denominator, and then we divide. Now, I want you to think of it more this way. If we're raising a fraction to some power, we need to apply that power to the numerator and to the denominator. So if we have a over b to the power of m, we rewrite that as a to the power of m over b to the power of m. All right, so we applied that exponent to both the numerator and the denominator. Let's look at a couple examples. Let's start with that quotient of powers property. Can we go a little bigger? Yeah, we can. Look at that. All right. So example 1, we're looking to simplify. Now what we have here is we are dividing two powers with the same base. So we keep our base of 8 and we subtract the exponents. So 4 minus 3 is 1. We subtracted the exponents. 8 to the power of 1 is just 8. So our final answer is 8. For our second example, with x to the 4th over x to the 7th, we're dividing two powers with the same base. When I divide two powers with the same base, I keep my base of x in this case, and I subtract the exponents. 4 minus 7 is negative 3. All right, we found that again by subtracting the exponents. Now, we know that we're not allowed to leave answers with negative exponents. It's not allowed. So what we're going to do instead is we're going to rewrite this. Now, I want you to think of this as x to the negative 3rd over 1. Okay? Which means we have a negative exponent in the numerator. Negative exponent tells me it's in the wrong spot, so all I'm going to do is I'm going to rewrite this as 1 over x to the 3rd. I have an x to the negative 3rd in the numerator, so what I do is I just move it down to the denominator, leaving me with 1 over x to the 3rd. Let's keep moving. On to example 2. Next page. Start with A here. Now, this is now looking at that second property that we learned, the power of a quotient property. All right? When we have a fraction such as 4 over 5, and we're raising that to some power, in this case 2, we need to apply that second power to the 4, to the numerator, and to the 5 to the denominator. So this becomes 4 squared over 5 squared. Now here's the thing. we can only use that property that we just used in example 1, that quotient of powers property, if we have the same base. In this case, we don't have the same base. In the numerator, we have a base of 4. In the denominator, we have a base of 5. So we can't do that quotient of powers property. So all I'm going to do is just evaluate the powers. 4 squared is 16, 5 squared is 25. I can't reduce that any further. My final answer is just 16 over 25. Let's look at part B. Now this one's kind of tricky. There's a lot of negatives going on here. We need to be very careful. So follow closely, and again, don't be afraid to pause the video to catch up. So here we have negative 8/5 raised to the negative third power. All right, the first thing I want you to do is rewrite negative 8/5 as negative 8 over positive 5. It's just going to make it easier to deal with. Now we're going to use that second property that we learned, the power of a quotient property, which means, since I have a fraction, negative 8 over 5, and we're raising that to some power, in this case a negative 3, we need to apply that exponent to the negative 8 and to the 5, to both the numerator and the denominator. That gives me negative 8 to the negative third power over 5 to the negative third power. Now, here's the thing. We have negative exponents. We can't have negative exponents. Since we have a negative exponent here, we know that's in the wrong place. Since we have a negative exponent here, we know that's in the wrong place. So what we're going to end up doing here is just flipping. Let me show you how. Negative 8 to the negative third power. I have a negative third power in the numerator. It tells me it's in the wrong place, so I'm just going to move it down to the denominator. So it becomes negative 8 to the positive third power of the denominator. Here I have 5 to the negative third power in the denominator. So I have a negative exponent in the denominator telling me that that is in the wrong place. So we're going to move this 5 up to the numerator, so it'll become positive 5 to the positive third power in the numerator. Again, negative exponents don't necessarily mean negative numbers. They mean that that number is in the wrong place. This one was in the numerator. It's in the wrong place. We moved it to the denominator. This one's in the denominator. Negative exponent telling me it's in the wrong place, so we moved it up to the numerator. And now we just need to simplify. 5 to the third power is 125. Negative 8 to the third power is negative 512. You can find both of those by just punching them into your calculator, leaving me with a final answer of negative 125 over 512. So again, be very careful with those negative exponents because, again, negative exponents don't necessarily mean negative numbers. It means it's in the wrong spot. Let's keep going. Moving on. Example 3. Now we're really talking. Now, what I want you to notice before we even start this is how many little details we have. Numbers, a couple variables, raise the powers. We need to be very careful to keep our work neat and in order so we don't lose anything. Okay? We're actually going to use basically all the properties that we've learned so far. Most of them anyway. Let's get started. Let's start by focusing just on the numerator, okay? So we're going to focus just on the numerator to start. We're going to simplify that. When we multiply a fraction, we know we multiply straight across. So let's start by multiplying the numerators together. Start with the numbers. 3 times 12 is 36. X times x to the third. When we multiply two powers together, I keep my base and I add the exponents. Keep in mind that's x to the first. So 1 plus 3 is 4. Now for my y's, y to the fourth times y squared is y to the sixth. So we just simplified our numerator. We multiplied the numbers together, the x's together, the y's together. Let's do the same thing in the denominator now. Because when we multiply fractions, again, we multiply straight across. 4 times, there's really a 1 there. So 4 times 1 is 4. Then we have x to the third times x to the second. When we multiply two powers together, we keep our base. We add the exponents. 3 plus 2 is 5. So now we've simplified our denominator. Great, but we're not done yet. Now we're going to simplify using that first property we learned today, the quotient of powers property. Here's how I want you to look at this. Looking at it as is, it looks like one really big, really tough problem. Let's break that up. We're going to break this up into 3 separate problems. The first one is going to be 36 divided by 4. The second one is going to be, get my right colors here. That should work. X to the fourth divided by x to the fifth. And my third is going to be y to the sixth divided by nothing. Let's simplify each one separately. Let's start with the yellow. 36 divided by 4 equals 9. Color those in as we go. X to the fourth over x to the fifth. When we divide two powers with the same base, I keep my base and I subtract the exponents. 4 minus 5 is -1. And y to the sixth over nothing else just leaves me with y to the sixth. Now, that should be our final answer, right? However, there is a problem. You should notice that we have a negative exponent. We cannot leave negative exponents in our final answer. So what we're going to do is we're going to rewrite this. 9 has a positive exponent, it's really 9 to the first. So that is allowed to remain in the numerator. X to the negative first, that tells me it's in the wrong spot, so we're going to bump that down to the denominator, x to the positive first now. And y to the sixth, that has a positive exponent, so that stays in the numerator as well. So this would be our final answer. Alright, so again, negative exponent doesn't necessarily mean a negative number, it just means it's in the wrong spot. So this was in the numerator with a negative exponent, so we moved it down to the denominator. Leaving us with this final answer. All right. Let's move on to example 4, probably the toughest one in this lesson. Let's get that to fit on the screen. Hopefully, there we go. So here we have b over a to the negative third power. I already don't like that a to the negative third power. Okay? I'm going to be moving that. It's in the denominator with a negative exponent. We're going to be moving it. We'll do that in just a second. Times b to the third power over a, all raised to the negative second power. So let's be careful to take this using order of operations. So the first thing I'm going to do is the exponent. I'm going to apply this -2 as an exponent to both the b to the third and a to the second. So my first part, the b over a to the negative third, I'm not going to change that yet. The second part, we are going to rewrite that as b to the third, write that a little neater, raised to the negative second power over a to to the negative second power. So I just applied that exponent of negative 2 to both terms, the numerator and the denominator. And now let's fix everything. I really don't like that we have negative exponents. So let's go ahead and rewrite using not negative exponents. Our b is fine to leave in the numerator. Here we had an a to the negative third in the denominator. I'm going to move that up to the numerator, because again, a negative exponent tells me we are in the wrong spot. And then for this whole mess right here, since we have negative exponents in the numerator and denominator, we're just going to flip. So we end up with a to the second power, or a squared, over b to the third to the second power, or b to the sixth. Let's simplify a little bit. So multiplying these, multiplying fractions, we multiply straight across. So b times a to the third times a squared would be b a to the fifth. Then on the bottom, 1 times b to the sixth would be b to the sixth. Then we can simplify using that quotient of powers. B to the first over b to the sixth is b to the negative fifth. A to the fifth over nothing else gives me a to the positive fifth. Since we have a negative exponent, we know that b to the negative fifth is in the wrong spot, so we just move it down to the denominator, leaving me with a to the fifth over b to the fifth. That would be our final answer. Let's look at those checkpoint examples, just to do a couple more. All right, let's start with number 1. Four to the sixth over 4 to the fourth. When I divide two powers with the same base, I keep my base, I subtract the exponents. Let's go ahead and write that out. Keep my base, subtract the exponents, leaving me with 4 to the second power. 4 to the second power is 16. Number 2. T to the 7th over t to the 8th. When I divide two powers with the same base, I keep my base, I subtract my exponents, leaving me with t to the negative 1st. Again, we can't have a negative exponent in our answer. So, we have t to the negative 1st over 1. We have the negative exponent in the numerator, so we're just going to move it down to the denominator. So 1 over t to the positive 1st. Here we're raising a fraction to a power, okay, so we're going to need to apply that square to the negative 5 and to the c. So we end up with negative 5 squared over c squared, which gives me 25 over c squared. Now we're going to make this a little bigger for the last couple of questions. That should be big enough. If I can get it to center, right? Cool. Number 4. 3 over 4 to the negative second, so we apply that negative second to the numerator and to the denominator. And then since both have negative exponents, they're both in the wrong spot. So we're going to move the 4 to the negative second to the numerator and make it a positive second. We're going to move the 3 to the negative second to the denominator and make it a positive second, leaving us with 16 over 9. Next, let's first start by multiplying. When we multiply fractions, we multiply straight across. We're going to do numerator times numerator. 5 times 24 is 120. X squared times x to the 5th is x to the 7th. When you multiply two powers together, add their exponents, keep the base. Y to the 3rd times y squared is y to the 5th. Again, when you multiply two powers together, keep the base, add the exponents. Now let's work on the denominator. So we're going to multiply denominator times denominator. 6 times 1 would just be 6. X to the 4th times x to the 6th is x to the 10th. And y to the 3rd times no other y would just leave us with y to the 3rd. Now what we need to do here is let's break this up, okay? I want you to imagine this as 3 separate division problems. The coefficients dividing each other, the x's dividing each other, and the y's dividing each other. Let's start with the coefficients. 120 divided by 6 leaves me with 20. X to the 7th divided by x to the 10th. When we divide two powers with the same base, keep your base, subtract the exponents. 7 minus 10 is negative 3. And y to the 5th over y to the 3rd, again, subtract the exponents. The only problem here is we have that negative exponent for x to the negative 3rd, so we just need to move that into the denominator. So we'll have 20y squared over x to the 3rd. And last but not least, number 6. So first, I am going to apply this exponent to both the numerator and the denominator. So let's rewrite this as a to the 3rd over b to the negative 4th times a to the negative 3rd over b squared. Oh, I'm sorry. A to the negative 3rd, because 1 times negative 3 is negative 3. B squared to the negative 3 gives me b to the negative 6. When you raise a power to another power, multiply the exponents. And now I think I'm just going to multiply straight across. A to the 3rd times a to the negative 3rd gives me a to the power of 0. When you multiply two powers with the same base, add the exponents. 3 plus negative 3 is 0. B to the negative 4th times b to the negative 6 gives me b to the negative 10th. So now I have a negative exponent in the denominator. I'm going to move that up to the numerator. And anything raised to the power of 0 is just 1. So we're left with simply b to the power of 10. These problems take a lot of practice. Make sure you are doing your homework and come to class ready with questions.